Hi, welcome to another lecture on calculus. We are going to continue our conversation about trigonometric integrals today by taking a look at a different type of a product than before. So you remember our plan was to look at various type of products. Some of these had the power of trig functions, but the argument itself was a single x. Now, sometimes the argument has a multiple in it, but we don't have powers to worry about. So it could be product of two sines, two cosines, or a sine and a cosine. By comparison to the previous cases, these turn out to be rather easy, provided that we remember a couple of identities from trigonometry. So again, trigonometry is playing a major role here. Let's go and remind ourselves about these identities. So here I have written some of these identities for you. You want to go back to your trig textbook or the end of this textbook to refresh your mind about these. So we had the sine and cosine of sum or difference of two angles. These are standard identities you see in that respect. If you take two of these things and add them up, the sines cancel and you will get product of two cosines. That gives you the idea that the product of two cosines can be written in terms of sum and difference of the two angles that are involved. So they are typically referred to as product to sum identities because here I have a product of two trig functions and here I have sum and difference of two angles. That's what these products and sums refer to. So if I have, for example, cosine of A times cosine of B, that's 1/2 of cosine of A minus B plus cosine of A plus B. And similarly for the other cases. So if I have product of two cosines and I want to integrate this thing, one approach will be to apply this identity and then proceed. After you do this conversion, it's quite easy. Of course, there are other approaches available as well. Let's just go ahead and use this one. So here, this tells me this is 1/2 of the factor of 1/2 I put outside. Difference of the two angles, so it's going to be cosine of nx minus mx, and then sum of these two, cosine of nx plus mx, and then the whole thing is times dx. Well, now I can factor my x here, so I'll have 1/2 of integral of cosine of n minus mx, and then here I'll have cosine of n plus mx. I have to put a double parenthesis here. I'm just going to make it a bit crowded, and another parenthesis. So perhaps sometimes we don't write all of these things, makes the situation very cluttered, but that's the correct way of writing it. So 1/2 of. Now antiderivative of cosine, it's just very basic formula. Cosine of, let's suppose I have alpha x dx. What's the antiderivative? Of course, it's sine of alpha x divided by alpha. This we write regularly, but sometimes we have to be careful. If this alpha is 0, of course the right hand side doesn't make good sense anymore. But if alpha is 0, cosine of 0 is just 1. Antiderivative of that is just x. So if you understand that accordingly, that this is in case alpha is 0, this just its limit, which is just x, or write it separately. How is that to be observed here? If n minus m and n plus m, neither of them are 0, then I can go ahead and write it like this: sine of n minus m. So if you excuse me, I don't put all the parentheses. N minus m, and then here sine of n plus m x over n plus m, and then you put a constant. So this is provided that n minus m is not 0, n plus m is not 0 either. In case they are 0, well, cosine of 0 will be 1, and you just write the antiderivative as just x and you're done, or interpret these things with a 0 denominator to mean just x. So we see that this type of integrations are very easy, in fact. And you might be wondering, where does this thing get to be used? There's a whole section of mathematics that also shows up in engineering. In mathematics, it comes up as partial differential equations, and in engineering it could be under any category, perhaps related to heat transfer or something like that. This type of integrals are quite common there in a topic called Fourier transforms, and it's a basic staple of that type of a discussion. As you see, the problem is very easy once you know the trig identities. It becomes a trivial step to take, but it's essential to have this. At the time that you took those trig identities, probably you didn't have that many applications presented to you, because of course it's going to be beyond the scope of such courses. But gradually all of those identities you see in a trig class, they get to be used in a variety of engineering topics, and this was one example of it, a connection from something that you have seen in high school with some advanced topics that we see later on. Okay, so this is going to be a super short lecture, and we are going to move on to other topics after that. So until then, good luck and God bless.